Hello everyone. This is a lecture on our chapter 2, velocity, distance, and time. It's our first equation and our first concept for physics. So I'm going over this via PowerPoints. So as we knew from last week, physics is the most fundamental physical science. It's concerned with basic principles that describe how the universe works, and it deals with matter, motion, force, and energy. Basic areas of physics are classical mechanics. That's basically what we're studying here, and that's how mechanical machines or how we move. We are going to touch waves and sound. We're going to talk about sound waves and light waves. Thermodynamics, we're just going to talk about energy and then heat. We will do the electromagnetism. And then there are other ones that are quantum mechanics. That's a lot higher order than we need to talk about here, in atomic and nuclear physics. And then the area of physics related to relativity. So we're going to talk primarily first about motion. So motion's everywhere. We're walking, we're driving, we're flying. Birds are flying, fish are swimming, it's everywhere. So we're going to talk about how we move. And so that's speed, velocity, and acceleration. There's basically two kinds of motion that when you're studying physics, things that are in a straight line, which makes it a lot easier for us, or in a circular motion. So if we're going to talk about a motion, you have to start talking about positioning. You have to look at where this let's say we're talking about how fast a car is moving. Well, the car had to go from one point to another. So you need to start to have reference points. So position is basically where the object's located. We just use it as a reference point. The motion is that the object's undergoing a continuous change in position. The description of the motion would be the rate of time and the change of position. So it's a combination of how far it went, length, and how fast it went, time. So if you think about it in words, if that describes how a motion goes, now we have to talk about it in physical terms. So in physical science, speed and velocity have different, distinct meanings. But it's only for when you're conceptually answering your quizzes and things like that. Speed is what they call a scalar quantity, so it's only magnitude. Magnitude, just refer to that as the number. I know that sometimes the wording in physics gets confusing. So a car is going 80 kilometers per hour. The speed is 80. 80 is just the number. So if we're going to get super technical for a minute, velocity is the same number. It is speed, but it's what we consider a vector. So that is more of the physics term, is velocity, because you're going to give it both magnitude, the number, and a direction. So if you see a car zooming by you and it went 100 miles per hour, that is speed, because all I know is the number, 100 miles per hour. If I said, oh my God, I was driving back from New York City and I was on 84 going east and a car passed me at 100 miles per hour, then that would be a velocity. They're still going 100 miles per hour, but now I know the direction that they're going. Do you get it? It's a very slight, distinct difference. So, in my mind, we're just going to go primarily, so what I have to talk about a little bit about is vectors. And they can be a little confusing at times. But vectors can be represented by arrows. So the length of the arrow is proportional to the magnitude. This is really great if you're going into an in-depth study of physics. So if you get to the next level of physics, college physics, you need to pay attention to all of this stuff. But since we're just an introduction to physics, we don't really have to go that far. I just wanted to show you. Obviously, the direction's going this way. That's the positive direction. That's why it says 40. If I'm going to the left, think of the number line. That's the negative direction, so that's why that is negative. 80 kilometers per hour positive is going to the right, but see the arrow is twice the size as the 40 kilometers. And again, if it's negative 80 kilometers, that means they're decelerating, they're slowing down, but they're going, the arrow's double the amount of the 40. That's all this means, is how they would represent vectors properly in physics. Note, vectors also can have both positive and negative, which I just said. So now let's go to our first equation. Now see, they're using speed and velocity in the same thing. So they're calling this speed, let's just call it velocity. So the average velocity is v, is equal to the distance you traveled and the amount of time it took. So now we're going to talk about it in physics language. Physics language is really equations. So v is equal to the distance divided by the time. Or v could be the change in distance over the change in time. So either you know, so you might know that it was, the car traveled and it was at one, it was at 0, but then it went 50 meters and it started at 0 time and it took 10 seconds. That's how you can get the 50 meters over 10 seconds. So the distance is the actual path length traveled. So the only thing you would need to know is instantaneous speed, and that's for your quizzes, your concept quizzes. The speed of an object and instant time. So when you glance in the speedometer and you go, oh my God, I didn't realize it. I'm going 90 miles per hour when you thought you were only going 75. That's just instantaneous speed. We're not going to really worry about instantaneous speed in our calculations. We're really just going to worry about the three units that we've talked about. So v is velocity, except now you would have a plus and minus to it, and it's really the distance over time. Now, they're using the word displacement. So displacement means a straight line distance between the initial and the final position with direction towards the final position. So this is where the book gets really critical. They're saying velocity, so if you look at it, you still have the average, I'm going to put my pen in here, the average velocity is distance over time. Well, they're just saying displacement over time, because displacement means you're giving it a direction. So what's the difference between displacement and distance? Distance is just the path traveled. That would be like in regular English. And displacement is a vector quantity between 2 points. So that's more of the physics term for distance. So you could be going from A, la-di-da, I walked around the lake and I got to this point. That's the actual distance that was traveled. But the displacement was, I started in this point, doesn't matter if I did twirly-whirlies or whatever, I got to B. So the distance was direct. Okay, now here's an example for velocity, distance, and time. And I'm going to give you some of these examples, but then I'm going to stop and I'm going to go over another lecture that is purely looking at the equation, how you would manipulate it, what its units are, and then I'll slowly do several problems on it. But I just want to go over this quickly. So, velocity. Describe the speed of the car above. So if you look at the picture, it starts at 0, and in 1 second it went 20 meters. 2 seconds went another 20 meters. 3 seconds went another 20 meters. And at 4 seconds it went another 20 meters. Right? So the distance it went was 80 meters, and the total amount of time is 4 seconds. So if I want to know what the speed is, the equation is v equals d over t. But now I have to rearrange, so Now I'm going to solve the equation. The distance is 80 meters, and you're going to divide by the 4 seconds, and so then you get 20. So 20 meters per second was the average speed that that car drove. Velocity would be described as 20 meters per second in the direction of motion, so it would be east. So if in a quiz you're asking the question, basically whether you solved for speed or velocity, it's the same number, 20 meters per second, but if you give it a direction, east, or you give it an arrow, or you give it a plus or a minus, then it's the velocity. I'm going to do one more. This one is how far would the car above travel in 10 seconds? How far is the distance? Okay, so what did we were given? So we are still given 4 seconds, and this car originally went 80 meters, but we're asking how far would the car travel in 10 seconds? So now you're going to use the velocity that you already calculated. You're going to rearrange the equation, so it's d equals v times t. And in my next lecture, I'm going to go very slowly and show you how you rearrange, because I know a lot of you need that step to go slower. And then you're going to solve. So it would be the 20 meters per second times the 10 seconds. And so the car went 200 meters. Here's another example. How long does it take sunlight to reach the earth? How long? That means they're asking for time. What was given? Well, you'd have to look it up, but the speed of light is 3 times 10 to the 8 meters per second. Look at the units, meter per second. That means it's a velocity. The distance to the earth, if you look it up, from, the sky is 1.5 times 10 to the 8 kilometers. That's pretty far. And so because it's just in meters, that's a distance. So if I look at the equation, v equals d divided by t, I got to rearrange it for t equals. So t would equal distance divided by velocity. And if we solve for that, we would put the distance, the 1.5 times 10 to the 8. This is in kilometers, so that would also be times 10 to the 3, and that's why you have the 11 here. Not quite liking the book's notes just because they miss steps for you. That's why I'm going to keep doing this in the next lecture. And then you're going to divide by the 3 times 10 to the 8 meters per second, so that your answer will come up in seconds. So your answer is 0.5 times 10 to the 3 seconds, which I would accept, or you could write it as 5 times 10 to the 2 seconds, or you could say 500 seconds. And that's a little bit about Chapter 2, introducing velocity, distance, and time. I'm going to go a little slower in my next lecture.